Okay, so good afternoon. My name is Andrei Burghelea. I'm going to present today my paper produced as a student at the Bartlett School of Architecture, named Architectural Aesthetics and Personality, an experiment to research the correlations between personality traits and visual preferences for complexity in architectural scenes. In the interest of producing metrics for the architectural stylistic preferences of groups and individuals, this paper explores the difficulty to quantify how much personality influences our aesthetic preferences in the context of architectural design. The disconnect between the aesthetic and spatial preferences of architects and the general population have been debated for a long time. Even though there are specific ways to evaluate the quality of a design with systems such as the design quality indicator, we still don't have a homogeneous system to quantify the aesthetic preferences of a population in a specific context. Exploration in this area are not independently meaningful, but they gain potential in the context of other fields. With the use of social network analysis, Twitter, Instagram, and Facebook are able to predict user preferences and forward them relevant ads. The ability to predict the aesthetic preferences of large groups is potentially valuable in contemporary industrial research with applications in business intelligence. Access to large amounts of data is an essential aspect that will allow faster advancements in this field. And with the continuous growth of social network platforms, this data is more available than ever before. Attempts to determine personality traits have been successful with the use of publicly scraped Facebook data. It is becoming easier to produce decent personality predictions simply based on the user interactions and preferences exposed on their social profiles. As shown in the past, any advancements in this area could risk the privacy of users and produce unwanted consequences. And any further developments will have to address user privacy and data processing carefully. A straightforward reusable method of discovering the aesthetic preferences of large groups could be a great asset in the architectural practice. This is another example of a work-in-progress experimental software that can collect Twitter user data based on the geographic location of tweets and perform analysis processes such as sentiment analysis or personality prediction. In this particular case, it is used to visualize a Twitter social network by geographic area, attempting to find alpha users or users that have the most influence over a network. And this is a 3D graph of the collected data. The paper uses an experiment to find correlations between personality traits and visual preferences for complexity within a population sample. The visual preferences were evaluated using a set of architectural photographs. There were some interesting findings where the overall participants' scene familiarity might not explain the high significance of the found correlations. An important tool in psychology is the ability to measure the personality differences between individuals. This can be achieved with the use of personality models designed to categorize and quantify these dimensions of personality. The current research uses the Big Five model. This is a well-recognized model in psychology constructed from 5 non-overlapping traits. Those are openness, conscientiousness, extroversion, agreeableness, and neuroticism. Each trait has 6 neo-subfacets that target the broad traits' finer characteristics. The slide example shows the subfacets of openness. By comparing the life satisfaction and personality traits from people based in the London area, we can see some links between their broad traits and the living areas. For example, people with high scores in trait openness linked with the desire of new experiences are more likely to cluster in active areas, while those scoring high in trait neuroticism linked with low emotional control tend to live in high crime rate areas. Our perception of architecture is extremely complex, and most certainly not everything can be predicted by pure personality traits. That being said, personality traits, trait personality provides 36 well-documented attributes that can have been used in the past to perform data-driven decisions in other domains. It's important to acknowledge that our perception is skewed. The effects of brain interference over our visual perception can be observed in patients that suffer from mild brain cerebral affections. Patients that suffered specific strokes that produced cases of left unilateral neglect have shown a preferential behavior for elements placed in the left side of their view. In a similar manner, cortically blind patients manifest environmental awareness, being able to react to visual stimuli, but are not visually conscious. Complexity is the biggest term in architecture. In this paper, complexity is strictly linked with visual perception. To produce qualitative measurements, the participants were asked to rate the complexity of the presented scenes based on the following sentence. In another phrase, how difficult do you find to describe the scene to a person with no architectural background? The participants were also asked to rank the beauty and the familiarity of each scene. The experiment aims to understand the predictability for architectural aesthetic preferences for complexity with the use of personality traits. Previous studies have developed a certain level of understanding in this area, but the architecture community generally considers personality too volatile and insignificant of a factor when the reported familiarity and attractiveness of a building is taken into account. Thus, the null hypothesis states the following: personality has no significant influence over an actor's aesthetic preferences for complexity in architecture. While the alternative hypothesis states there is a significant correlation between any aspect of personality and the actor's aesthetic preferences for complexity in architecture, independent of his familiarity. The collected data is qualitative and consistent in participant background information, a series of rated architectural photographs, and the results of a personality test. The participants were sampled from varied occupational backgrounds, but the majority have undergone some form of architectural schooling, being part or alumni of University College London or University of Greenwich, most having Romanian nationality. The experiment was split into 2 sessions and used a small sample size. There were 21 participants that completed the first session, but only 10 completed the second one. That being said, only the results from the double session participants were taken into account for the analysis, while the other 11 were used as a low value form of result validation after the experiment ended. This diagram shows the experiment timeline for each participant. The first session was longer, containing a general participant data form, IP 120 personality test, followed by an image rating formula with 54 photographs of building exteriors, interiors, and surfaces. The second session only contained the image rating formula with a different set of 54 images. 3 sets of 36 images were collected. Those represent the exteriors, interiors, and surfaces that were part of specific buildings from Russia, Germany, United Kingdom, Hong Kong, Italy, Romania, and other. All images were scored and classified using computer vision scripts. This was done in order to create a ranking for image complexity, mostly based on edge density. After the images were classified into 2 groups using the initial ratings to ensure that the scenes were evenly distributed. Participants were also shown 2.5D images along the standard bidimensional counterparts. Those provided extra information about the building scale and overall volumes. A custom software was built to collect data from participants. It was designed for ease of use and to organize the data. I wanted to streamline the data analysis process with the aim of making it scalable for any future use. Each participant was supervised in an online one-to-one conference setting. They're allowed to ask the examiner any experiment-related questions. All session time slots were agreed with the participants at a time of their own choosing. The collected data was clean. We organized, standardized, and analyzed using Pearson correlations and univariate regressions. A more detailed process will be presented during the 3rd sessions of this conference. The aesthetic preferences were standardized within the group and labeled as low, medium, or high in complexity using the participant rated values. Had some interesting results within all 5 dimensions of personality, but I want to start by saying that it's very likely that the optimistic nature of those results might be influenced by the high sample variety in the personality traits. The most obvious example is within openness, where even though the means between the groups were similar, the difference in variance was very high, with a value of 60.4 in experimental to 89.5 score variance at control. As previously mentioned, I target both subtraits and broad traits in my analysis. I'm going to present the most interesting findings, but before I want to give some context, this table contains the shortened definitions of the 5 broad traits and the name of their subfacets. We have openness. The more you score on this trait, the more likely you are to seek new experiences. This is very linked with aesthetic desires and artistic pursuits. After is conscientiousness, which tracks the proclivity to maintain work ethic and attentiveness, linked with career and academic performance. Extroversion or extraversion, which makes a person more assertive and sociable. Agreeableness, characterized by interpersonal cooperation and friendliness. And neuroticism, which tracks emotional control and proclivity of forming negative emotions. We first have openness. 3 of the most interesting results are: within general high complexity, there was a highly significant positive correlation at ideas. Within general low complexity, there were 2 highly significant negative correlation at aesthetics. and also at fantasy, subdimensions of aesthetic openness. This suggests that people with higher scores in openness might consider higher complexity more beautiful, while disliking lower forms of complexity. There was a highly significant positive correlation in high interior complexity at achievement striving. One positive significant correlation in exterior medium complexity at competence, and a highly significant negative correlation in medium surface complexity at order. In extroversion, there were highly significant negative correlation in low general complexity and highly significant positive correlation in high general complexity, most obvious at gregariousness and a broad extroversion. In a similar manner, high interior complexity showed highly significant positive correlation at broad extroversion. This might mean that higher score in extroversion might predict preferences for higher complexity. Within agreeableness, the most consistent finding was a highly significant or negative correlation within medium complexity surfaces at broad agreeableness. And within neuroticism were some highly significant negative correlations in high interior complexity, self-consciousness, and vulnerability, which make me think if aesthetic complexity might be disliked by people who score high neuroticism, or maybe the existence of a possible confounding variable. Multiple univariate linear regressions were used to further test the discovered correlations and to analyze how much of the model variety can be explained by user rated familiarity. Surprising is the relationship between high general complexity and intellect, which has no basis for the influence of familiarity, but accounts for more than half of the variability in the ratings. Broad extroversion shows some small connections with familiarity within the same typology. Interesting is also the high significance of self-consciousness in high complexity interiors and broad agreeableness in medium complexity surfaces, which were influenced to a lower degree by familiarity. In all of the cases, familiarity seems to have a highly significant influence. Further research should aim to improve the current formula with the adjustment of the data collection, processing, and interpretation. The experiment needs to be replicated and tested using larger sample sizes. Other scales need to be tested in addition to complexity, familiarity, and beauty. Some interesting options are assertiveness, warmth, and order. Other models such as Hexaco can be proposed as alternative to Ocean. Their overlapping and exclusive features and the use in the study of aesthetic preferences should be researched more attentively in the context of architectural aesthetics. Further research should test the utility of self-training neural networks in recognizing distinct connections between the data sets of participant-rated attributes and their personality traits. And I tried replicating the results by using the survey data from the separate group of 11 participants. I compiled the data and attempt to produce the results, reproduce the results within intellect, self-consciousness, agreeableness, and extroversion, but no significant correlations were found. It's important to know that this data lacked in quality compared to the initial run. Even though highly significant correlation were found between personality traits and preferences for complexity, irrespective of their rate of familiarity, I still mark the results as inconclusive. I believe that the results are overly optimistic and have been affected by the sample size, experimental limitation, and personality trait distributions. One interesting observation is the effect of repeated testing. In their first session, both groups had higher score means and variety in different of the image sets. This suggests that the participant might have some sort of adjustment in between sessions or the presence of an unidentified latent variable. I consider trait personality to be only a good starting point in finding elements of aesthetic synchronicity in humans, and any further advancements should be careful to not invade user privacy. I hope that the current paper has brought forward an interesting perspective that could inspire the development of new tools and processes for architects. And thank you very much for listening. Looking forward to any questions.
Thank you very much, Andrei. Fantastic, really interesting.